This is ClueCon Weekly, the official FreeSwitch web show produced and broadcasted directly from FreeSwitch. ClueCon Weekly features live updates from the FreeSwitch developers and presentations from various pioneers of communications technology. ClueCon Weekly is brought to you by FreeSwitch Solutions, the official consulting firm of the FreeSwitch open source project. Get help from the experts. Visit freeswitch.com. ClueCon, the premier technology conference for telecom, WebRTC, IoT, and all things maker. ClueCon is held every year in Chicago, Illinois, and offers an all-day hackathon and 4 days of technology-rich presentations from developers around the world. Learn more at ClueCon.com or call 877-748-CLUE.
All right, guys, welcome to ClueCon Weekly. Today is August the 30th, and we're going to have Varun Singh from callstats.io joining us today. He's going to be talking about collecting call stats for various things and some of the cool stuff they've been working on over there for helping you get those call stats on WebRTC, SIP, and other things. So, guys, stand by for that. First, let's go over to Miss Kathleen King for the news.
Thanks, Ken. First, we have a wonderful event tomorrow at 11 a.m. Central Time US. The OpenSIPs team will be joining us for a live OpenSIPs FreeSwitch integration demo. This is a great opportunity to watch a live walkthrough and get all your questions answered, so don't miss it. Mark your calendars. We've got a Facebook event. We've got the YouTube channel already set up. Make sure you do not miss out. And then early bird registration for ClueCon 2018 opens September 1st. Plan ahead. If you already know you're going, why not save some money? Register early. Tickets will be $6.99. Don't miss out on that, and there may be a special prize for the first one to register. And then we are looking into expanding our training selections, and we're going to be sending some requests and information for some feedback. Please keep an eye out for those announcements, and let us know what you think. And then for those of you attending AstroCon this year, come by and find us. We will be there. Anthony will be speaking. Brian, myself, Sharon West, we will all be there. We'll have a wonderful little booth set up. So make sure to stop by and say hello. And that's it for me, Ken.
All right. Thank you very much, Kathleen. So today we're going to have Varun joining us. Varun, how are you doing today, sir? Thank you. I think you're muted still. Let's get you unmuted. How are you doing, Varun?
Yeah, thank you for inviting me in. It's a pleasure to speak to the FreeSwitch community. Really excited about the talk, so let's get to it.
All right, man. Yeah, so let's go ahead. I'll turn it over to you. Let's get your screen share up and take it away, Varun.
Cool. So good evening, folks. Thank you for joining us speaking about callstats.io at the FreeSwitch community call. So I'll start with talking about myself, what I've been doing the last 10 years. So I started working with video almost 12 years ago, or 13 now, in 2004, for a semiconductor company doing the camera device drivers. And I moved up the stack. So I went from hardware to device drivers to the middleware, and then I was writing applications for video. And a few years ago, I got a Ph.D. in congestion control, and all my work was about making video crispy, beautiful for consumption. And I started basically contributing to standards, both to the RTP spec and to the W3C. And more recently, I've been involved with the WebRTC Statistics API, which was recently updated again in the summer of 2017. And I did that work with Harald Alverstrand from Google and the folks at W3C. So it's a combined effort. And I've been spearheading the statistics work all around the IETF and the W3C, mainly around video. So when I started building, when I graduated, I started building a company. And at that time, when I was talking to a lot of people who were just starting out doing WebRTC, one of the things that I noticed, because I started building a WebRTC app myself, and notice I kept running into quality issues, performance issues, network issues. And I started talking to other folks around me, and they were having the same issue. And while building that app, which didn't get very far, we started building out what would become CallStats.io eventually. And at that time, when we started pivoting off of that app into this thing that we were using to collect data to analyze our own network quality issues, we decided that we're going to do it as a software as a service because we noticed that some of the issues that we were facing were common to a lot of people at the time. And one of the things that we noticed at the time was that all the people who'd been running all the SIP stacks, they were basically collecting data. Well, they were on-prem, they were collecting data locally, and they had the whole tool chain set up locally to manage that infrastructure. But they could not basically take stuff from elsewhere and plug it in. So we started with software as a service, and we decided early on that the data would reside outside so that we could build pipelines. We would keep, we would harmonize the data over time. If the data structures would change, we would maintain that. And lo and behold, it paid off because the WebRTC stats, both the API and itself has transformed a lot over the last 3-4 years since I took over writing it. But also the implementations have not usually kept up. And there are maybe 5 or 6 or 7 variants of the API and the outputs of those APIs. And there are a lot of people who are trying to make sure that they get the same output. So CallStats, of course, helps with that because we collect this data, harmonize it, and store it. Today, we have a lot of integrations across the board. So we have integrations with Jitsi, we have integrations with the SIP community. So we have JSIP, SIP.js, Twilio, PEXIP. So all the gateways connecting to, not all, because we don't yet have Asterix, but and FreeSwitch integrations. Although we know some people have done those themselves. And then we have Temesis, Vox Implant, and we have a lot of others that we don't know of as yet. So if you're building a platform or own an SDK and would like to contribute or get CallStats integrated with that, we'd love to hear about it. If we can support you in any way, we're happy to do that. So because we have so many integrations, we actually support a multitude of topologies. So both the mesh, so you have companies that do not have a server component, and then they get 2, 3, 4, 5 people in a call, and they're all sending data to each other. Or you have a conference server, which may be like an audio gateway or a video gateway or both. It may be doing, it may be an MCU where it might be scaling the video, or maybe an SFU where it's selectively forwarding. And we've got integrations with all of these components in some way. So we have an integration with Jitsi, Janus, Curento. So all of the SFUs, we have some of the old MCUs that have been integrated by our customers. But at the end of the day, what we do is we get data from all the endpoints. And so typically, in the simplest case, there is a JavaScript library that's integrated into the web app. It may be a REST API endpoint as well, so you could integrate it into native apps or server components. And then we collect this data and send it to CallStats infrastructure. One part of the complexity is getting all this data, and the second part of it is to be able to crunch it in real time. So typically, you see all the graphs and everything as the call's ongoing, maybe half a second, almost an RTT delay, but that the data comes in and you can pretty much see it on the dashboard immediately. So that was one of the beauties of building this product in 2012-13, when a lot of the technology was already mature in terms of infrastructure, scalability, reliability. So we built up on a lot of open source components like Kafka, Storm, Postgres, MongoDB, and so on and so forth. So when we started, so I'm going to start from why we did this. So this picture, I've been using it for the last 4 years, has been correctly empathizes with the user. We do know that users have latency issues, they have jitter issues, sometimes they don't have good quality. And a lot of the times when we talk about quality, we talk about bandwidth. And Because when we talk about high quality, we always say like we need more bandwidth. Like if I want to do 4K video, I need like in excess of 10 megabits per second. If I were to do 1080p, I need 5 megabits per second, and so on and so forth. But if you're going to do real-time communication, it's not about the throughput or bandwidth. It's about latency and delay. You'd like to be able to get our message across in a very short amount of time, like hundreds of milliseconds, and get a response from the other side as well. So for example, this is a call from like a few years ago, maybe last year. It's only an audio-only call, and you can see, there are small peaks, and then towards the 200 second, you have a large peak, and then like so on and so forth. So the red line right in the middle is basically what is the RTT like expected by ITUT, which is about 120 milliseconds one-way delay, 240 milliseconds RTT. And what you see is like for the beginning of the call, these peaks are pretty much lower. Off and on they go up, but at 200, like as soon as you go past 150 seconds, there are like large peaks, and that's where the call becomes terrible. And we're talking about audio only, very low bandwidth, less than 50 kilobits per second, and we're seeing this behavior. And we want to measure, and that's how we started building CallStats.io, mainly because we noticed that it was not a throughput question, but an audio latency or latency issue. So just to recap, we collect data across the pipeline. So we collect data from the sender side, from the receiver side, send it to CallStats, and basically crunch both the sender side and the receiver side in real time. So that basically means that we're collecting data across the pipeline from the track, the sender, the transport, the ICE transport in both directions. If the media is going in both directions from each participant across this pipeline. And how we do this is, for example, we collect the data and we want to know, like, so for example, in this call, you can see the frame width. It's just shy of, it starts at 1280, very quickly drops to 960, drops to 640, and then stays there for most of the call. And then at some point in the middle of the call, it starts to flap. So it goes from 640 to 960, then goes back down, then goes up to 1280, comes back down, and goes back to 640, and then drops to 480 towards the end of the call. So this would be like an odd behavior because you know that it's been stable for most of the time, and what triggered this. And maybe a customer reports this by saying, like, in the middle of the call or towards the end of the call, I had issues, and you can go and dig through this. And the next thing you would want to do is look at, okay, so you see that frame width changes. What happens at the throughput level? And you can see, like, for most of the call, like, there were troughs or dips throughout the call, and then towards the 1600, you can see, like, it dips below, then it comes back up, dips below, and comes back up. And that's actually the same point in time where you can see the frame width also vary. So you know that this is somehow related to the throughput variation. And you can dig deeper. You can basically say, like, oh, was it related to losses? Maybe the throughput dropped because there were losses, and I would like to see that. And you notice that at the same point in time, there were actually no losses. So it gives you an understanding as a developer how to, like, go about this. So this is just a very quick recap on, like, collecting data across the pipeline and trying to correlate it to find a causal reason for someone reporting an issue. So going back to CallStats.io and why we measure user experience and how we measure it. So the main thing is that we measure the user experience from start to end. So that means from the time the page loads, and you press a button to maybe initiate the call, or when the page loads, you're already in a call. We measure all that part of it. Then we try to measure the call setup time. Was the call setup performant? Was it quick? Did you get the first media packet fairly quickly, or did it take a lot more time? And then we analyze that bit. And if it took a lot of time, why did it take? Did you have IPv4 candidates, v6 candidates, which caused it to take more time? And then during the call, once the call set up, you want to measure call experience, which is where majority of our quality score comes from. Like we measure it, we measure skewness, we want to see the at the end of the
we're losing your audio there, Varun.
Okay. So maybe I'll step closer. You hear me better now?
Yeah, I think
okay. Yeah. I wish we had a dashboard here for this call. So at the end of the call, people can report their call feedback, and then that could be input to customer support or to algorithms that would look at the feedback and say like, oh, let's see if there would be a causal relation. Can we find a causal relationship by correlating network events or media events to see if the feedback was poor because of something. As I said, we measure setup times. We are very, very like anal about it. We like try to get measure each and every bit of it. So we have all these events. We know when the connection started, when the connection ends, when the first media happened, was received, when the ICE candidates were gathered, when did they start checking against each other, when was the first one to succeed, and so on and so forth. And then we have all these measurements. The most important measure that we feel as that every service provider should be looking at, apart from setup delay maybe, is time to first media. So when is the first picture or the first sound heard by the remote endpoint? And that's the more important thing, because you might be able to set up the call, and then you might have one-way delay or one-way audio, which would basically cause the time to first media to be very large, but the setup delay could be very low. So being able to get time to first media for measure it and then see if it's something that's reasonable for your service is, I think, a very important thing. And as I said, there are gathering delays, there's connection delays, and if you're engineers, you can figure out how to reduce this and probably tune these in a way that you can get the time to first media to be low. And when I talk about quality, and a lot of people in the industry talk about video quality or audio quality, so I basically consider quality to be three parts. One is the network metrics that everyone talks about, like bits per second, the RTT, the round trip time, which is the jitter, the packet losses. And then there are some people who talk about the media pipeline metrics, which is like, was it high quality video? Was it low quality video? How much was the playout delay? Was the audio video in sync? And so on and so forth. And then there's a bigger thing that I believe that the industry should be spending more time on, and that is annoyances, which I feel does not get as much prime time voice for it. So I'll take a few moments here. So what I feel is annoyances, which are like resolution changes, frame rate changes, interface changes. So you're doing Wi-Fi and then you have to switch to 3G. Does that happen automatically? Is it as seamless as possible? The resolution changes, did they happen because you switched to screen sharing, or was it just within the because there was bandwidth constraints? And these are all annoyances. In some use cases, these are more annoying. In some other cases, they may be less annoying. And if you understand the use cases well enough, then you could measure these annoyances better. And the last bits are about failures, especially like, for example, I was talking about the Wi-Fi 3G case. You might be on a Wi-Fi and you walk out of the door and the 3G does not kick in because maybe the app developer did not do it, or that the 3G interface is not available. You have to do it manually as an end user. That's quite annoying. So we measured that and we surface this information to our customers. So another way of looking at annoyances is being able to not look at the raw metrics, but to look at something as aggregation. So we have something called conference timeline, which I think is quite innovative. So in this case, you have like these graphs. You have Doc and Marty, and they have like a quality graph, one going high, one going low. But just above it is the conference timeline, and you can see that you have an event timeline which has no depth or height, and basically we just overlay events on it. So you can see right in the beginning of the call, around 5 minutes in, there's high latency, which we call was disrupted because you had high latency or low bandwidth, which caused the other person not to hear you very well. And then there is another thing in the middle where your connection was lost and you were disrupted. So although you thought you were connected, you were not able to get any data across. So that's an innovative way of showing this information so that customer support people, engineers, product managers can very quickly glance through a timeline and see like if there were a lot of events or few events, and if there were few events, what those were. And if there were a lot of events, maybe they should have a closer look at the end user and see if they're still unhappy with their experience. So I'll show you some examples on how we use this data or how we expose the information on the conference timeline. So network disruptions, and we know this happens a lot, and sometimes we have these situations where someone has low capacity, loss of connectivity, high delay, and they're not able to hear the other person or see the other person clearly. So in this case, you can see like this light gray line on the third user 626, which is roughly from the first minute all the way till the 10th minute, where he has some issues with quality of video and audio with one particular user, which is E6, and he can hear 47. He can hear the other person very well, which is 47, but he cannot hear E6 very well. And this is basically a very quick way of understanding that problem. Another way is when media freezes. So for example, in this case, you can see that for the first person, Martha, the media was not frozen, maybe in the beginning and then towards the end. But for Andrea, the video was freezing quite often. So it was suspended, it was resuming, and there were resolution switches. So things like this, like on the media pipe, on the conference timeline, you can see disruptions in media very quickly, and you can really quickly understand if the user was, the state of the user's expectations. So like it was really bad towards the end, it kind of stabilized in the middle, it was okay towards the end of the call. Another thing that we noticed was the fact that sometimes we know that when we are on a call and we can't hear the other person, we try to toggle our audio and video. And we used to do it ourselves, and we thought, oh, maybe we should go and look at our data and see if this is something. So we productized it. So we have an API where the customers can integrate basically user events, which would be audio pause, audio resume, video pause, video resume, switch screen share, and so on and so forth. And what we did was we looked at our disruption events and overlaid these two together. What we noticed was that a lot of the times these events would come in a flurry. And we actually see a very good example here where all three users in a call are basically self-diagnosing their connection by turning off their video and audio when they had disruptions. And this basically means that the user was slightly annoyed. These set of users would be slightly annoyed because they would have to self-diagnose this issue by themselves. And of course, after a few seconds or tens of seconds, this was resolved and they continued the call. So another example of annoyance to measure quality of experience. And as I said, we collect user feedback. This is another one where a person gave a score of 3, and he says in his language, in his words, it kept breaking every few minutes for 20 seconds, which was very, very accurate, because if you see user A and user B, so user B is reporting that user A was disrupted in some form, and you can particularly say that every few minutes, and the width of it was roughly about 20 to 30 seconds. So like what we've observed is user feedback sometimes is very in sync or correlated with what we experience or we see on the network side from the statistics. Another thing that we noticed was when people speak, we also want to know if they're having a conversation or are they basically reporting. Excuse me. So, for example, we have something called conversation dynamics, and you can see that. So the green thing shows whenever a particular person speaks, and whenever if the person keeps speaking, the green stays with that person, and as soon as the other person speaks, it turns to the other person. And you can see, like the first example with Casper, they speak a little bit, and then there's a question or an answer, or question, and then there's an answer, there's a question, there's an answer. There's like basically it's like an interrogation, let's say. And then the second example, you can see Glenn, they go through that phase in the beginning of the call, and towards the end of the call, they're basically talking to each other at very quickly. So they're having a conversation, and you can actually see that from other statistics as well. But getting this upfront basically helps you do better customer support, because if they were talking over each other or talking to each other, maybe you can understand if they were doing a good enough job or not. And if they had any disruption in this period, it would be a little bit more annoying because they would have to speak a lot more. And a lot of people talk about, oh, we could measure this through audio throughputs. And one of the examples that I show here is that you should be able to see only one graph because they're supposed to be speaking and they're not speaking. And what you notice is that basically the audio throughput is pretty much the same throughout. Maybe because of comfort noise and other reasons, security reasons for sending audio all the time, so that people do not, no man in the middle would be able to say who was speaking when. And there's another thing like diagnosing in real time. So after we saw this observation a couple of years ago, we productized it. And what you see here is that user A, so marked by 1, 2, and 3, basically switched instances. So you came onto a call, did something, then swapped to another browser or to another window, came back into the first one, did not work, switched to a third window, and then worked. If you were in an interactive scenario to ask why or what do you think might have happened, I'll just give you the answer now. So it's one-way media. So one person's already on the call, he's speaking, but the other person can't hear, and he's switching between browsers, closing browsers, switching off the app, and does that unsuccessfully for a certain amount of time, and then comes back and it starts to work, and then they have the conversation. And we productized this a year ago. We started measuring it and started sending alerts to people. We surfaced a JavaScript event on the library so that the app developer could collect it and then basically tell the user that, hey, you might have one-way audio. These are the instructions that we have currently, and then expose that to the end user, and hopefully the end user responds to it in some form. So that was the first bit about call stats and what we do with the product. The second bit, I believe, a little bit more interesting one, is about the state of WebRTC as we observe it. So we do a WebRTC report almost on a quarterly basis. There's a new one that's coming out in a couple of weeks. It's called Industry Report. So you can go to callstats.io/industry-reports. The latest one, the third one of this installments, is coming out next week. There would be a fourth one coming out soon after in October. So the two reports coming, and this is data from the previous plus the new ones put together. So what do we see? We see browsers, and we see a lot of browsers. So about 70% of our data is from the browsers. 30% of it is from native apps. So keep that in mind. Keep also in mind that this data is based on what CallStats measuring. It's about 500 products, big and small. Some 150, 200 of them are medium, large volume, and so there's a bias in this data, particularly because it's CallStats and whoever's using CallStats. So 30% native clients, about 70% browsers. What we're seeing is like a move towards a lot more participants. So this is from a year ago, so July, August, September last year. What we're seeing is that one-party calls or two-party calls and three-party calls, 2 and 3-party calls are like quite more often. Less often is 4 and 5. So there are lots of use cases where people are doing a lot more people on the call. But what we've seen, especially in normal collaboration or contact center kind of scenarios, it tends to be between 2 to 3 quite often. So the numbers are, of course, leaning towards that. And it's still about the same even this year. Media streams, it's quite a lot of it is audio and video. About 20–30% is just video, just audio. So still a bias towards collaboration apps. Setup failures, we have setup failures before setup. You can see that over the last year, numbers have come down. It's at about 2–3% failure rate. That depends a lot on how you measure it. We are quite aggressive about it. So if there are 4 people in a call and 1 person is unable to join for whatever reason, we classify it as failure. Although some people might say like, oh, it was kind of successful. But what we see is that the numbers around 3%. This year was earlier this year it was at 2%. There's some slight variation over the last few months over this. And another metric that a lot of people are curious about is about the turn relay. About what we see today is 20%, about 20 to 25% of the calls go over turn. That's interesting. That means that companies that want to build peer-to-peer still need some form of infrastructure, either it's their own or someone else's. That's an interesting question. But nonetheless, to get into corporate, one of the examples that I talk about, which happened sometime last year, was an app that deployed to about the age group of 17–18 years old children or young adults. And over the summer, and basically it was doing very well until it came to August, September, when they basically started seeing a high volume of failures on their calls. And after a few days, it was discovered that, the students or the pupils went back to school, and the schools have very restrictive firewalls. And a lot of the failures were happening because they did not have adequate turn relay servers, and it was just because the beginning of the school season, and they had not anticipated that or had not taken that into account when they were building the app and during the launch, which was over the summer. So that was an interesting learning for us as well, because there were, like, our app was reporting on a particular day that they had more failures. They were certainly, and we were on call with them and diagnosing it until we realized that, in fact, that was correct, that their turn servers were not sufficient turn servers. And then there are setup failures after the call has been set up. So this is the drop scenario. So users lose connectivity because they are on bad networks. There might be battery loss, so you run out of battery, or there might be bugs in implementation. So what we noticed is that high delay, high loss contribute about 30% of the call reestablishment reasons. So people drop out and either redial in or reload the page. About 50% of the calls are because of connectivity loss, and there might be people who have to reestablish the call for that. And about 20% of the reasons are one-way audio, where people suddenly lose connectivity, or at the beginning of the call cannot talk to the other person and have to employ either another browser or switch to another tab or close the current tab and rejoin the call. And that basically will constitute as a crash or a reason for the pipeline to crash. I'll just quickly jump through these slides, which are maybe more interesting for some people. What we've noticed over the last few months is the RTT. What we measure RTT, and we noticed that about 80% of the time, the 95% RTT is under 200 milliseconds, which is really cool. That means that's under the guidelines of the IETF. Of course, we're not measuring the last 5%, so you might have like a long tail there. But we believe that for long sessions, 95 percentile RTT is an adequate measure of measuring RTT and not the average RTT. Average throughput for audio, 70% of the audio sessions have an average throughput of 45 kilobits per second, which is also cool. That means that you can do Opus, you can do a lot of other types of codecs, and kind of gives you enough room to get medium to decent quality audio across the network. And lastly, we have the average throughput of video, where you can see it's a flat line basically. For under 500 kilobits per second, we have about 20%, and then like a linearly 10% for 250 kilobits per second. So there's about 10% calls that do 2 megabits per second. There's about 10% of the calls that do 1 megabit per second. So like it's quite a nice gradient there. Let's skip through that. The last thing, when we talk about quality, and it's about call stats, so about 28% of the calls, or about 80% of the calls, people say it's acceptable or high quality video and audio, and only 10-11% of the people complain about dissatisfactory audio or video, which is really good. That means that WebRTC is ready for prime time. A lot more people happy with it than unhappy with it. And this has changed and evolved over the last few years as we measured. And our own objective quality metric that we see, it's a bit, it underestimates the quality a little bit. We want to be like saying the quality is a little lesser than it might actually be, so that we don't have false positives. So what we notice is about 78 or 80%, 88% of the calls are good or fair or excellent, and only 12% of them are poor, which correlates very well with the previous slide where there were 11% people complaining about the bad quality. So that means that the quality metric is highly correlated to the user feedback in some sense. And one of the lessons learned was deploy turn servers with TCP support. We've seen a lot of apps which are growing or enter a new market or enter a new country or a continent or a new region or start a new app. They tend to run into these kind of connectivity issues. There's also issues with crashes and disruptions, and a lot more people are putting in the effort of reestablishing these connections automatically. So when the media pipeline crashes, they try to do something. Screen share plugin crashes, they try to do something else. And if network is lost, they try to reestablish the network. So a lot of the SDKs, a lot of the app developers are rolling these features into this. And what we are seeing as an outcome of that is that the quality is improving. People are actually happier with the quality of experience. So just to quickly summarize, so call setup failures are around 2%. Number of participants on a call still remain around 2 to 3 people. 75% of the calls that we monitor are audio and video. 25% are audio only. We see about 20% relays, and for 66% of the calls, the call setup within less than 1 second. 80% of the calls have less than 200 millisecond RTT, and for about 70% of the calls, the audio throughput is more than sufficient. And for video, we noticed that about 50% of the calls have over 1 megabit per second, which is perhaps pretty good for a lot of the use cases that we have today. And lastly, we noticed that about 89% of the people, based on user feedback, find the quality of call acceptable, and about 88% based on our own objective quality metrics, we see 88% of the calls are fair or good. So that's the end of my slide deck. If you have any questions, I can go back on the slides. I'm happy to answer any questions.
I've got a question for you real quick, and have you guys done any monitoring on the video side of things? Whether people are using higher resolution or lower resolution video streams for like video conferencing and such?
Yeah, we actually, as I said, about 75% of our calls are video. Some use cases are screen share only, where they tend to do just video screen sharing and audio. There are some other use cases where people are just doing, lots of small videos because they're sharing, like they're casting between offices, and they just want to have, unless someone knocks on or wants to talk to another person on the other side, they just have like a small thumbnail refreshing every few seconds, which tends to be either low resolution or low frame rate go through. You have a lot of collaboration apps which do simulcast or something similar.
Well, and when people are actually not doing the thumbnail stuff, what would you say the average resolution they're doing? Is it like 360p or 720p or even 1080p?
Right now, I think a lot of it is because of Chrome and like what people pick as defaults on Chrome. So I would say something it's between 720p and 480p. Like that's, I would say it's somewhere between that. I would say the average would be somewhere in between the median. Like if you were to do a median, it might be closer to 480 than 720. There are very few people who are doing 1080 today.
I think we're one of the few people that does 1080 by default where possible.
Yeah.
Because it uses a lot more bandwidth. But anybody else?
Yeah, I think it's also.
Sorry.
Yeah, go ahead.
Oh, go ahead, Varun. I was just asking anybody else have questions.
Yeah, I said like the 1080 tends to be problematic with some set of encoders, decoders, some browsers do not behave very well. So I wouldn't say like it's more like a endpoint question right now than a network question. At least we've seen a lot more people try 1080, but very quickly like drop down in resolution because they notice that the person's hardware is either not able to do it or the video is freezing for some reason.
Cool. All right, guys. Anybody else have any questions for Varun? Now's the time to get in here and ask those questions while we still have him. All right, well, cool. Well, Varun, I want to say, let's see, any parting words you want to get in before we let you get back to your day there on the other side of the planet?
Yeah, sure. Like, I think the last comment I would have is the WebRTC report's coming out very soon. We'll probably send out a blog to you when it's out so that you can share it with the community. But if people are interested, they can go and sign up for updates or newsletters from our website. You can go to callstats.io and there's /newsletters should get you to sign up for a newsletter.
All right, cool. All right, well, we will definitely do that. For everybody that's watching us on YouTube now, look down at the bottom of the video. You'll see some of the URLs that Varun has mentioned. You'll also see that subscribe button. Go ahead and click that, and you'll get the updates on when we're going to be doing these videos in the future. You'll find out who's coming to ClueCon Weekly. And also, don't forget, tomorrow, we're going to do a special thing with OpenShips. They're going to be here at 11 a.m. Central to show off some FreeSwitch and OpenShips integration. So you guys join us then. Also, let's see here. Who do we got? We've got several guests. Kathleen's got the schedule like full for us all the way for like the next month and a half, 2 months. So you guys be sure to check that out. She'll be posting those to events on Facebook. So be sure you like us on Facebook so you get those alerts also. Thanks, guys, and we'll see you next week.
You've been watching ClueCon Weekly. Tune in every Wednesday at 1 p.m. Eastern Time, or visit us online. Please follow the FreeSwitch team on Twitter and Facebook by visiting our site at freeswitch.org.